Hey all, just a little experiment in weld testing basically. This is a Series 2 front door hinge, the top of the door, and I've just welded some 6mm mild steel plate to it to recreate what Land Rover offered on some of the vehicles. I think they're on Dormobiles and stuff like that. So you could have a hinge mounted mirror. So that had a round rod, that's attached there, and then the mirror was adjustable on the arm, as opposed to having them mounted on the wings or to the front of the windscreen or whatever. So these were a solid cast steel one piece thing that Land Rover did. They are somewhat available, pretty hard to get, and they're very expensive if you can get them. So you can just do something like this. But the sort of question came up: how well does our weld attach to the cast steel? Cast steel as opposed to cast iron. And the only way to find out really is to have a bit of a go and do a destructive test. So I didn't want to do this one because that one was sort of half decent. So I had a spare hinge here, so I just got the same plate and just welded a section to it, and then just made up a little jig here and the bolts just to support that end. So instead of just belting it putting in a vise or something and belting it with a hammer, I wanted to do it a little bit slower to see where it would fail first. And so I'm going to just try and put it in my press and just press it slowly around here, and hopefully this will sort of support the hinge, so we're only getting this stress through here through the weld. It's welded both sides, as is this one here. Just TIG weld, and we'll see how. I did notice that this particular hinge here, it didn't weld as well. The tacks did crack, so that'll be interesting. It did weld once it got a bit more heat into it. So once it heated up from tack welding, it sort of came good, so to speak. But there's always going to be slight differences with things like that, impurities or whatever. They're both cleaned the same, thoroughly cleaned the same. So, I'll go and put this in the press and set it up, and then we'll go and see how it goes. This could let go straight away. I don't know. This is not really a structural component, but it's just an interesting exercise. A few bits of scrap. I'm able to do it. So, this is how you can learn certain things or improve your techniques or change things to make an improvement. We'll see how they go. Okay, I've got the little jig set up on the press. It's all a bit bodgy here. It'll be interesting to see if this little clamp at the back can hold it, because it's going to be pressing off center, so it's going to want to tip the jig over, I think. So I've had to clamp it in there, but we'll see how it goes and see how the weld holds up across there, and see if we can get this to start to bend. It's a 30-ton press, so it'll have no problems causing havoc. It's just whether or not we can have a reasonable result. Okay. Don't particularly want something to go flying either. It's a good recipe for disaster. We've nearly reached 1 metric or imperial ton, although the low end of the pressure scale is going to be somewhat inaccurate. The scale's not going up. A little bit. So we've definitely got some good bend in the plate. Can't see any failures yet. Any cracking? I can't hear anything. Piss poor lighting. I'll go a bit more. Oh, focus. So that's a US ton, and it's, you know, we've reached past yield and of the material, so it's just not going to go any higher on that. It's just whether or not the I don't know how much twist we're getting in the. Yeah, the hinge is leaning over a little bit on that end. I did do these rear bolts up pretty tight, but again, you know, it's a bit of a cobbled together setup. But at the end of the day, the steel is not just broken straight off the weld or off the hinge. That was me. Zoom in a bit. This is, I tell you what, these new iPhones are terrible cameras. There we go. Oh, is that some cracking? Yeah, beautiful. Down the middle of the weld, which is a good sign because it hasn't let go off the edge. So, you know, often when they let go along the very edge of the weld, you know, if so for example, if it's the same material, that's the heat affected zone, that's an issue. It's a separate issue. And if we had this, the whole weld peel off, so on that edge there, it's definitely on the edge, but then it goes towards the middle there. So we're going to have to get this to fail so we can see there's a bit creeping up to the edge there. So, but if my concern was it was just going to be a straight line all the way along the top edge of the weld where it meets the cast steel, and just basically the weld sticking to the mild steel plate and not really at all to the cast steel hinge arm. That crack's opened up a lot more through there. You can see the deformation between, I mean, the hinge itself is buckling. That was all flat up the mount, and this hinge will have twisted quite a deal. It's very hard to see, but I'm going to put my finger around here. So this, terrible filming, sorry guys. This bit here has canted over towards the ram, and that's like it's twisting the hinge arm itself, because this here has not twisted over towards the ram or towards me as much as the other end. So it's definitely twisting that arm, which is a good, you know, that's a good sign for the weld that it's doing that before it's just, again, just let go. We could have some bolt projecting out the back of this thing pretty rapidly, I think, if we go too much more. Oh, there we go. That's really opened up along there now. Interesting. Good. That's what we want. Just a nice, soft, safe failure in the workshop. So what I'll do is I'll retract the cylinder back up. So we'll see how it looks. So there's a good amount of weld left to the hinge itself from here, but I'll undo it all and I'll take it back to the bench and we'll have a look at it. Okay, back here at the bench, first thing I'll do is I've got these sitting the same. If we come down on this angle, you'll see the difference. The one on the left's the one we've just destroyed, and see how much it's twisted compared to the one on the right that hasn't been. I mean, so that in itself, you know, that's twisted that hinge, that cast steel hinge, which is, you know, reasonably strong, a certain amount before it's failed. And that hinge is useless now. That's completely deformed, that hinge. So, you know, that's a success in itself in a way, and it's not good for the hinge. But as far as the plate attaching to it now, this is the top edge. This is the bottom. We were pressing in this direction, so we had tension in the top welds because we were stretching, pulling it, where we had compression in the bottom weld, the underside weld. And if we go in there and have a bit of a look, there's chunks of the hinge itself, the cast steel, missing, as in they've come with that. So that, again, that's a good sign. There's a big chunk under my thumbnail there, missing, and various pieces through there, through there, and there. There's a couple of little pieces here, but again, this was getting pushed in compression. And there's some of it where it's just the weld's gone in half. So half of it's been left behind here and half of it's on the plate. Again, that's quite a good result. This was never designed, like I never set it up to be a full penetration weld. It doesn't need that, you know, the job that the hinge is doing for the mirror. And I think we've proven that, you know, you're going to do a lot more damage to the mirror arm and the mirror before you have failure of this, and potentially you're going to buckle the hinge and have to throw the whole thing out anyway. So, you know, there's chunks of the cast steel left there. So, I think that's a pretty good result, really, to see that that it hasn't just left a smooth, sort of flat surface there, and that we've got this jagged edge in a way, like we don't have a smooth edge along there at the top edge of the weld where it's just peeled off, you know, like glue that hasn't stuck to one of the two surfaces. So, and you can see there's half the weld all the way down that lower weld, and that would be the other half through there. So that's really good on the compression side. The top side, it probably would have been nicer to see a bit more left on the hinge, but in saying that, it's pulled out of the hinge itself, so it hasn't just left it, you know, let go. So, and the plate itself, plate is still fairly flat. I mean, in a perfect weld, you'd have a bend across here, but I mean, maybe it would have been different if we did it more out here. I mean, look where the point is on the, you know, with this here, you're going to deform all of this well before it lets go through there, because there's not much material left around here. So this is just going to fold over here like a pretzel before you get, you know, to a point of having it affect the weld at all. So I think that's a fairly good result for that little part, and just a little bit of information that gives back to me as a welder, thinking, like, for when I say welder as in a hobbyist, for saying, oh, you know, what I'm doing is on the right sort of path for this sort of thing. And you know, definitely some things I can look at, maybe a bit more preheat. I don't think I wanted the amp set any higher, because you're getting to the point where with that, you know, there's almost undercut, like it's the edge bleed into the material there is really nice. If it was any hotter, I think I'd start to get undercut in the parent material, and we don't want that. You know, undercut's a terrible stress riser, and it's you know, it's not good. Like the edge there is really nice bleed into the parent material on both sides. It's not like a straight over roll where it's like that. It's coming in nicely. to the surface, and it's not gone in underneath the surface, and created a line or an edge there that you could run your fingernail in, which is undercut, and that can be really bad. So, yep, good one. Cheers.